Dear students, now we will start the most important part of mathematics is calculus. What do you mean by calculus? Calculus is not a chapter. Calculus is the union of 3 or 4 chapters. One is limit, continuity, differentiability, integrability and differential equation. This is called calculus. Before we start calculus, we have clear-cut idea about the functions. There are several types of functions we have already discussed. That is polynomial function, algebraic function, rational function, trigonometric function, inverse trigonometric function, logarithmic function, exponential functions, all are things. And what is the domain and what is the codomains. Now we will start limit. Limit of what? Limit of a function. So what is the limit of a function? Function means it has a domain set and codomain set. The limit of the function means the image of the point approaches to another point. Then when the pre-image changes, then image also changes. For your clarity, suppose my hand is here, so there is a image. Now my hand is here, so there is a image. This is called the pre-image, but this is called the image. When there is a change in the pre-image, there is also a change in the image. Though their approachness may not same, the pre-image may or may not equal to the distance of the image points. What is the limit of a function at a given point? Let f is a function from x to r and a is a point which is a fixed point. And f is a function from x to r, x is a variable point, a is a fixed point. Since f is a function, then every point must have the image points. X, what is the image? Image is fx. Let L be any real number. Then we say that fx tends to L when x tends to a. When there is a change in the pre-image, there is a change in the image, though their approachness may not same. That's why the distance between x and a we taken as that is delta. The delta is always greater than 0 because this is the distance. Similarly, fx and L, this is also distance. Suppose this distance is epsilon. This is also greater than 0 because the distance is always greater than 0. The distance between any 2 points is always greater than 0. That's why epsilon is greater than 0 and delta is also greater than 0. So when we say that x tends to a implies fx tends to L. Though their approachness may not same, that means the distance between x and a is x minus a mod less than delta implies fx minus L mod is less than epsilon. When this happens, then we say that limit x tends to a, fx is equal to L. This is the definition. Let f is a function from x to r and a belongs to x which is fixed and x is a variable point. X may here, x moves around a. Similarly, the image of x means fx moves around L. L belongs to R. Then we say that limit x tends to a, fx equal to L. If and only if for every epsilon greater than 0, there exists a delta greater than 0 such that x minus a mod less than delta implies fx minus L mod is less than epsilon. Fx minus L mod is less than epsilon. Now we expand it. X minus a mod less than delta means a minus delta less than x less than a plus delta which also implies x belongs to the open interval a minus delta to a plus delta. This is the geometrical figure. Suppose a is a point. X approaches to a. X may here, may here, may here, may here. X may here, may here, may also here. X approaches to a from the left or from the right. There are two possibilities arises. When x belongs to the open interval a minus delta to a plus delta, at that time if fx minus l mod is less than another small number, then we say that limit x tends to a, fx is equal to l. That means limit x tends to fx equal to l if given epsilon or for every epsilon greater than 0, there exists a delta greater than 0 such that x minus a mod less than delta implies fx minus l mod is less than epsilon. You remember only this. When this happens, then we say that limit x tends to a, fx equal to l. Now there is a question. You may ask, sir, x tends to a implies fx tends to l. The distance between x and a is less than delta. The distance between fx minus l is less than epsilon. This is a distance and this is a distance. This is greater than 0 and delta is also greater than 0. Now the delta depends on epsilon, but epsilon is not depends on delta. Delta always depends on epsilon. This is the number line a. Suppose x here. This is a minus delta, a plus delta, x. Now x approaches to a from the left of a is called the left hand limit of a. Similarly, x may approach from this place means the right side of a means limit x tends to a plus. जिते छोट पॉइंट देले भी a plus something जिते पाख देले भी a minus because x tends to a means x not equal to a. X approaches to a, that means the distance between x minus a mod is less than delta implies fx minus l mod is less than epsilon. In that case we say that the function, the limit L is the limit of this function fx when x approaches to a, means limit x tends to a, fx equal to L. The delta always depends upon the epsilon. Now to explain, we worked out one problem. Now to this is the definition of the limit. Again I remind you, we say that limit x tends to a, fx equal to L if given epsilon greater than 0, there exists a delta greater than 0 such that x minus a mod less than delta implies fx minus L mod is less than epsilon. That means the distance between x and a when less than a small number at that time, the distance between fx and L is less than another small number. In that case we say that limit x tends to a, fx equal to L. Now the question is, sir, x tends to a, fx tends to L. Why you write fx is equal to L? Suppose हम परिवा किनला बेले हमर होची 3 टंका 25 पैसा 25 पैसा अछि, आइदर हम 3 टंका दउछे और 3 टंका 50 पैसा दउछे, 50 पैसा भी नहीं. That means 3 टंका 25 पैसा is the approximate value, no, that is the exact value. Now we will discuss the approximate value, means the limiting value. That's why limit x tends to 2x plus 6 equal to 8, we prove this. Now compare with the definition. When we say that limit x tends to a, fx equal to L. What is fx? Fx equal to x plus 6. What is L? L is equal to 8. What is A? A is equal to 2. Then we prove that limit x tends to x plus 6 equal to 8. Let fx equal to x plus 6, L is equal to 8, A is equal to 2. Let fx minus 8 mod less than epsilon, which implies fx equal to x plus 6 minus 8 mod is less than epsilon, which implies x minus 2 mod is less than epsilon, that is equal to also delta. And when x minus 2 mod less than delta implies x plus 6 minus 8 mod is less than epsilon, then limit x tends to 2, x plus 6 equal to 8. In this case, the epsilon is equal to delta. That means in physics, in case of the plane mirror, the object distance equal to the image distance. But in case of the concave mirror or convex mirror, the object distance may or may not equal to its image distance. In this case, in this example, the object distance is equal to the image distance. Epsilon is the distance between the images and delta is the distance between the pre-images. In this case, delta coincides with epsilon. Similarly, there are also several examples. We can also prove that epsilon is greater than delta and epsilon also less than delta. This is left to the reader. But this type of evaluation of limit is not always possible. It will be very tedious. To avoid that type of difficulties, we start some standard laws of limits. Before we start the standard laws of limits, let me define what is a left hand side limit, what is the right hand side limit, what is the relation between the left hand limit and the right hand limit.